a gentle introduction to R. Welcome to today's class. Thank you for having me again today. Last week we didn't do anything much. We just installed R Studio, and we installed Git. So I believe you saw the videos, or the video rather, and if you didn't, please consult with Ulama. She will show you. Maureen, you didn't. You said you couldn't see the video, yes. So please consult with her. No, but there's nothing really much that we did there. Okay. So I'll proceed with the presentation now. We're going to discuss, briefly. We'll just look at data. We'll look at functions. We'll discuss a bit about the working directory, the workspace, R scripts, and then about resources. Okay. On to data. Now, everything about computing in general has to do with data, and R is no exception. So, yes, I'm recording it. So everything has to do with data. Everything about computing has to do with data. So when we're talking about R or any other language, data is at the core. What happens, essentially in R is that the user provides an input. It may be a number, it could be a character, it could be a word, it could be a sentence, it could be anything that is data. It could be a picture, for instance. So the user provides inputs. The input is processed, and then R gives out something, an output, or it carries out an action. For example, you could put in a command, and then R will open a file for you. So that's just what happens. Now what we have below there is we have I wish I had the pointer. Maybe when NS comes, you can provide it, the pointer. Point at the. So we have a block of code there where I wrote, this is a comment. R ignores this line. You see that line it starts with a pound sign, or what they call hash. Can you see it? So any line that starts with a hash or pound or whatever you call it, it is a comment. When you put that line there in R, it will be ignored. It's not a part of the code. It's not part of the what we pass as an instruction. It's called a comment. So you can write anything there. Usually when we are writing code, we put in comments to explain what is being done, because the code is not written in English or in any regular language. But you want to give somebody who is reading your code an insight as to what you're doing. So you now write comments. So comments are like a must when writing code. And even for your future self, you yourself who is writing the code, if you don't write comments, somewhere down the line you will not even know what you wrote. There's this axiom that they have in computing. It's like a joke, but it's a very true statement. It says, when I wrote the code 6 months ago, it says only I and God knew what I wrote. After 6 months, only God knows what I wrote, because even you wouldn't know. So that's why it's very vital to write comments. And that's why in every computing language they have a provision for comments where you can write even the whole paragraph of anything you want, just to explain what the code is all about. Okay. So we have here two comments. The first one is just to example. Then I now have to type in hello world. So I now typed in hello world, and then that line there with the 2 pound keys is the output from R. R has given us back what I gave it as, hello world. So this is what R does. If you just give it something like that, it will just, if without any other special command, it just returns it to you as a printout. All right. Now the second one, you see, I wrote 42. I typed in 42, and R gave me back 42. Okay, so this is just to demonstrate the input-output thing. Okay, and I will demonstrate some of these things, as we go. Okay. Now R can also perform computations. Okay. So we have 18 plus 4. Remember, I was telling you about input-output. The input here now is 18 plus 4. R has now given us an output of 22. 22 minus 4. R has now given us the output of 18. 18 times 6. That's star. The star or asterisk in R is a multiplication operator. So 18 times 6, the answer is 108. And then we have 18 divided by 6. The forward slash is a division operator in R. So 18 divided by 6 is 18. So you can see it's just like input, output, like that, okay? We have this other one, 18. This is called a modulo. This is percent. It's called modulo. Modulo 5. Now, what modulo is, in case you're not into maths, modulo is when you divide a number by another number, whatever is remaining is the modulo of that operation. So 18 divided by 5 is 15. Remainder 3. So what we have here is the remainder of that division. That is what modulo is. Then this other one is 3. We have this symbol is called the caret, C-A-R-E-T. If you on your computer keyboard, usually it is when you by the 6th key, number 6. If you hold shift and click and press 6, it will give you the caret. As on most keyboards, not all keyboards. So caret, 3 caret 2, that's 3 to the power 2. That's what we're doing here now. 3 to the power 2 is equal to 9, and R has given us the results. Okay, so this is just basic arithmetic. Now variables. In order to work with data, in computing, usually what we have is we take data that is in memory. For example, now we are putting those numbers when we're typing. We gave R a number 18. Now, if you want to work with that thing, you have to create variables. And variables are simply data that has a name. You give it a name, it becomes a variable. In R, there's an operator that we call the assignment operator, which is like an arrow. If you look at that second bullet, you see that there's an arrow there. That arrow you create it by typing less than and dash together. It will give you the arrow. So this is called the assignment operator, and the assignment operator is used to connect a name with a value. Okay, so in that example code now that we have there, we see X assignment. Okay, assign 18 to X. That's how you say it when you're, if you are conversing, in R, you say assign 18 to X. All right. So what we now have is in memory we have a value of 18, but it's called x. Okay. Are we together here up to this part? All right. Now I made a comment there that you can also use that equals to can also be used to assign. If I put that instead of putting that arrow, if I put equals to, it will give me the same result. But usually when we're coding in R, we prefer to use this arrow like thing, for reasons that I will not go into now. But by the time we do other, maybe down the line, you will see why it is good. It's not good to use the arrow. I mean, it's not good to use the equal sign to avoid confusion, because the equal sign does many other things. In even like now, if I can write equals for for other things. Now we have a variable called x that we have created. If we run x in the R console, any value that x contains, it is what R will spit out for us. So which we have done here now. I typed x in the console and it gave me the answer. X is 18. X is 18. So it's that simple. So what this means that we have a variable x that is stored in memory. It is called a variable because we can change the value but retain the same name. You can use the same name and just change the value by doing the same thing over and over and over again. So I assigned 108 to x, and when I ran x, it gave me 108, and that's why it's called a variable. It changes sometimes as you like. You change it. Okay. Now you can also add. You can add another variable and use it to use it in the computations. So here I now said y. I assigned 6 to y. Okay, so y becomes 6, and I say x plus y, just like you have in algebra, x plus y, and it gave me the result 114. So it added what was in x to what was in y and gave me the result. Okay. Now if I may choose not to print it out directly, I may now choose to put the result of this computation into a third variable, z. So I now say x plus y, assign the result of x plus y to z. Okay, so if I now run z, you see it is the same 114. So I now have another variable that I have created with the result of the other one. Okay, so you can do this as many as possible. There are many possibilities. All right. I asked what happened here, but I've already told you what happened here. Okay. So now is this variable value thing, variable value, assign a variable, get a fresh value. This is what, if you're doing anything in R, you keep doing this over and over again. That's just all that keeps happening. Okay, no matter how complex, the operation is still this basic back and forth that keeps happening. Okay. Now, one common trick is to use an existing variable to alter its own value. So I have a variable x with the value of 108 currently, and I now say, okay, I want to divide x by 12 and put the results in the same x. So x will change its value, but the operation was carried out upon x itself. So x divided by 12, the answer is a new x, which is now containing a value of 9. All right. Any question from here? Any question up to this point? No question. Praise. You're following, right? Good. Now functions. Everything that happens in R is done with a function. Everything that happens in R, everything that is an action, is always done with a function. Now, for example, we have a function in R for computing the square root of a number, which is called sqrt. That's the function's name. Now we had x, which has a value of 9. We want to compute the square root of 9 of x. We now run the function sqrt open parenthesis x close parenthesis. Okay, so this will give us the result of that computation. Now I want to ask a question. What is the value of x now? 9. Does anybody agree with her? Huh? Good. So the point I was trying to make here now is that the value of x has not changed. The value of x itself has not changed. What R did was to take x, whatever was in x, and to carry out a computation to get the square root of x and give us the result. But we didn't assign that result to any particular name. Okay, so x has not changed its value. If we had said assign this thing to x, if we had said x, put the arrow before writing square root x, then x will now change its value from what it was before to the new to the result of this this computation. Okay, so now functions in R I usually have they usually come in this format where you have a name and you have this open and close parenthesis. Like you saw that square root, it has the open and close parenthesis, and then we put in the arguments inside those parentheses. So that's just basically how functions one, and that is how we use them. If there are arguments to supply to a function, you put them inside those parentheses to do the operation. And of course, a user can create his own function. That's what makes R a programming language, because you can on your own create your own functions, which I won't show you here now. Maybe in a future lesson I will show you how to create your own function, and it's very, very easy and straightforward. Now the working directory. When working in R, I think at this point let us open up R. If we have R installed there, so just open your R installation. Just go to this and just go to Windows, click on your Windows key and type R GUI to open R. To see something like this there. Are we there? You can, I think, yeah, some of you even have it on desktop, the shortcut. Maureen, you have a desktop icon for it. You should have. So just open it from there. Are you there? Yes, that's right. Okay. So this is our R console. Okay. Where if you just follow me and type that X and just say 9. So to type this, you type X, type less than, then put a dash that gives you the arrow, and then put a space, just the way I did it, so it looks very clear. But even without space, it will still work the same way. And then something like this will happen. You will not see any output initially. It will just work invisibly. But how you know that it works is that the cursor, the prompt has a fresh prompt has been supplied. Watch my mouse here, my cursor here. Sorry, this is the prompt. Remember I was telling you last week. This is the prompt. So the console always gives you this prompt to tell you where to type next, and you see your cursor is there blinking. So when you now when you see this after you type in something, when this thing appears, it means that thing has successfully run. If there's a problem, it will tell you either error or warning or whatever. Okay. Hold on, Maji, are you having any problems? Are you good? Are you okay?
I'm fine.
Okay, fine. Now, have you done this X assign 9 to X? Have you done this to it, Maureen? Have you done it? Okay, now if you now run X, just type X alone, you will see an output. Okay. Can I continue? Oh, is there a problem? Can I continue? Okay. Back to the slide. Then you just leave your R open. And also, as I'm speaking, you are free to try out some of the code on your own. Yeah. All these lines here that are highlighted in this with this gray background, they are the code. Okay, so it's something you can always try it on your own. Now, when working in R, you are always working within a given directory. It's called the working directory. All right. If you're not familiar with what we call directories are just folders. Okay, they are folders. And when you're working in a console application, you're always working within a particular folder. All right, and R is a console application. The commands we're writing are all within a console. So it has to be within a location on the tree of folders that you have on your computer. It may be documents, my documents, it may be music, it can be anything. All right. So whenever you are working in R, you are working in a given directory. Now, in the console, unlike your Windows, when you're in Windows, you can always know where you are. Explorer, you can easily see it. This is the folder where I am. But in the console, you can't see it. Okay, unless you test it. So there's a test in R to know what is the directory where you are in right now, and that is a function called getWD, short for get working directory. When you type in getWD, it will spit out your current working directory. It will show the path to where you are. Okay, so this is where I am, or this is where I ran this when I ran it. Okay. So if you do something similar on your own console, you can type this there right now. Type getWD, open and close parentheses, and you hit enter. It will show you where you are. Okay. Then to change the working directory, you need to write the path to the new one that you want. For example, this function here, I wrote set working directory, set WD, and I'll say, okay, I want to go to desktop. Okay. This character here, called the tilde. Are you familiar with this character? Okay, is there on your computer? It varies. It varies from. Well, it depends on your keyboard. I don't know. But you should find out where this character is. And this character is usually it represents your home. What we call your home directory. All right, are you following me? Are we following? Please, if there's any issue, just let me know. Don't get lost. Now, are you seeing this? I did the selection here. This C. In Windows, this is C drive. which is your hard drive. And this is the folder users, and this is my folder called admin. Okay, this is my home. This is home for my own computer. It may be different. It may be different for yours. But this is home for my own computer. Now this tilde here represents this from here to here. Okay. This tilde here, this wave symbol, represents this to this on Windows for my own computer. Now, if I come to your computer, this one will be different. Okay, but with this code now, with this code, all of us have a desktop. Isn't it also? All of us on Windows have a desktop. We have a folder called desktop. With this code now, this code can run on any computer because we all have the same. This will work on my own, to work on your own. That's why we use this tilde. Is a like a code for home directory. Are you getting me? And that's why it's useful. Okay. I just said let me just throw it in here so you just you understand. Now set WD will set your working directory. If you run this set WD now, it will change your directory to desktop. And when you run get WD again, you find out that the thing has changed to desktop. So you can try it out. If it doesn't work for you or you have an error, let me know. Now it is strongly recommended for any given project that you are doing, you should have a unique working directory. And that's why I introduced this particular function. You must have every project you are doing in R should have its own folder. Everything is going in there. Anything you change should be in that folder. If you have a different, okay, let's say now, let me just give an example. Maybe you're working on, let's say you have an outreach, right? An outreach in, okay, let's say you have outreaches, and you're picking data on outreaches, Owerri, Enugu, blah 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 blah, okay? And you have a big database you are generating, with different things you're doing with it. You're storing the data, you're uploading it to your website. Different kind of things. You are doing analysis, checking the graphs. Doing different things with the data. It should all be in one folder. You call it your working directory. If you now have something you are doing, maybe, okay, like the other time we were talking about audio files, video files. You want to store them in a database. You pick a different folder and do that one there. So it should be in its own working directory, not with the one you did in. Because you see, when I came here, one of the things I saw was that the data flying here and there, different things, mixed up, jumbled up. You don't do that. So with R helps you to organize them in folders. You call them projects, and to record everything you're doing per time as you're changing them. You understand? Okay. Now the workspace. Now, what the workspace is essentially in R is just call it your working table. Let me not even say workstation. This is where all the data you're working with in any session resides. Okay, anything you are doing in that session, it will be in your workspace. Now to display the contents of the workspace, you use the ls function, which is short for list. So if you type ls, open and close parentheses, no additional arguments supplied, to list out everything that is in that workspace. Now look at this place here. We have some output here. We have x, y, z. If you remember, these are the three variables we created earlier on. So they are there in the workspace. All right. I will not go into the details of what actually a workspace is. That's in deep. But just for now, just imagine that you have a desk, and you have maybe some documents you are working with, and those documents are on that tabletop. That is your workspace, and that's how it is. All right. You can remove them. You can add new things to it as you're working. So to remove you can remove something from the workspace using the rm function, short for remove. So when you just say rm and then put that thing in the function, it will take it out of of the workspace. So when I do, if I run rmz, it will remove that variable called z. So what we have left there will only be x and y. Okay. If you want to remove everything from the workspace, everything that is there, want to make it empty, you just you type the same function, but you now supply some parameters to it that are different. Now, this is the parameter. It says it's called list. That's the parameter, and the argument we are supplying is essentially everything in the workspace. And if you remember, this function ls returns everything in the workspace. Remember, back here. Okay, this ls gives you everything in the workspace. Now, when you send ls to remove, it clears everything in the workspace. So you have seen here now how two functions can interact, because every function, or not every, most functions have return values. So that return value can be used to supply something to another function, and that is what happened here. The return value of this function here was applied to this one, and it now used that one, removed everything that was in the workspace. If you type ls again now here, you will see that is empty. Okay, you will see something like character 0. Nothing else. Nothing is there. Now our scripts, we're almost done though. It's not a long distance. Now our commands can be saved in a text file called an R script. I mentioned this to you last week. Now, how do R scripts work? You see, this is. Let me just open this R console. This is the R console, right? Let me check where I am first before I type anything here. Get WD. I don't want to do anything outside of this folder, so I'm not in the right folder where I want to be. So I'm going to just watch as I'm doing it. I want to just quickly go over to this folder so that I keep my work organized in one place. Oops, sorry. Now, I want to clear my screen. There's a command there, Control L. Will clear my screen. Now I want to say set working directory. I see it clearly from here. Yes. Set working directory. I open the parentheses and I put in. I'll use the tilde expansion. Documents. Do you see how fast that thing went? I'm going to give you. I'm giving you tips along the way. In R, if you are typing something, if you supply the first 3 characters, if you hit tab, it will complete it for you. So always use that if you can. Always use it, because it helps you to avoid typographical errors. Because in coding, even if you miss a comma where there should be a comma, it will just give you an error. All right. So documents. Where is this in now? Okay, somewhere here. Okay, so this is where this is my working directory. I've changed it. Let me confirm it. Get WD again. So this is where I am now, right? I'm in this folder called training. I want to list the workspace. What is there in the workspace? X is there. Something called X. Remember I made X before, which happens to be 9. All right. I'll clear whatever is there. I'll clear X. I don't want it. I don't really need it, right? No. So X is gone. If I say ls again, we'll now see just be character 0, but nothing is there in the workspace. All right. Okay. Now we're talking about we're about talking about R scripts. Now R scripts, you see, all these things are they are commands. This is a command I've written. This one is a command. This one is a command. Okay. Now all of this I can put them in a script. All right. I shouldn't be doing this, so I shouldn't be doing this. Okay, let me just do it for today. When I'm working with if I'm showing people, I like to stick to the command line. You can, so it helps you to understand how the different functionalities that are there. So this is just a text environment. So I can put in all some of these things that I did here. I can put them here. All right, as our scripts. So let me create something again. If I say right. Remember I told you about comments, right? So I'll put a comment here. Make a variable x. Okay. Now, follow me clearly. Again, we are reminding ourselves nothing is here. Okay. Now, instead of typing and typing endlessly, every time I want to use R, I can create a file where I write down my commands in a script that can be run over and over again by myself or anybody. Okay. Now to run this, if I want to run this line by line, I will say Control R. See, it has run the comment here. Make a variable x. Okay. Then Control R again. Have you seen? It has done it. And if I now say this one, what is x? That's the result, 9. Okay. Now I will now save this script the way we normally do it in this folder where I am already. And I'll just call it make x. Make x, and it becomes make x dot r. Okay, and I close it. So that script is now in the folder, and it can be run at any time. Okay. Now I was telling you about telling you about R scripts. Let me open this thing again. Make x dot r. You can see that I've brought in another function now called file edit. So if you notice that when I ran this function, or this script rather, it started from this line by line, and it was carrying out the operations. When I write it, it jumped from this line to the next line. So R always reads from the top to the bottom like that, from the top to the bottom. Okay. And then it reads each line from right to left. Okay. And the reason why this is important is because at times you may have maybe a mistake in your code. That is maybe more than one mistake on on one line. R will complain and say there's an error when it spots the first mistake. It won't identify the one that is after it. All right. Let me show you an example. For example, I want to put something here, something stupid here. I'll just say OBJ. Now I'll run this again. There are many ways you can run this in though. You can run it from here as well. If I click here, it should run. The Control R. It says error. Object obj not found. Okay. So and then your script has stopped. Now this one here now. I'll put something here. I'll put a comma here, and then I'll put what did I put here? Then you put another comma here. I want to run this line. This line should give me an error. Oops, sorry. Error. Unexpected what? Comma. In X, comma. Can you see it? Alright. I'll fix this thing now. I'll run it again. Error. Unexpected comma. In X assignment, comma. So you see what happened here is that there were two commas that were errors in the code. But the first time that he saw the error, he didn't see the second one. He only saw the first one. And that was where the code stopped executing. But when I fixed it, it now saw the second one. So what this shows is that R reads from right to left. It reads them like one by one, like from right to left. Okay. It will only stop once it sees that you may have 10 errors here. It will only stop when it sees the first one, and you keep on stopping until you fix all of them, one by one. Okay. Because why it's important to know this is because at times when you run into some issues, you need to wonder what's happening. You know what I mean? So this is why that happens. Okay. Okay. Now so the last bullet there, R doesn't foresee errors beyond the point where execution is stopped. Okay. Now, okay, well, I've already done the code demo. I said I will do for you. So I've already done it. Now resources. This is going to be our last bit. The R documentation. Now your R installation comes with a rich set of documentation that you can easily access via functions. Like I said, everything you do in R is based on functions. So there are functions that you just type in to give you something useful. So there's a command here called help.start. If you just run this, it open there's what is called the main help page, the main help home page. So you just try it out there on your own now. Type it now and try it out. Type help.start. Open and close parentheses. And let's see what happens. Yeah, so that's the main all the R manuals and everything are there. Okay? Did you get it? You didn't get it. What do you do? It's good to fail. It's good to fail because you learn from the failure. So what do you do wrong? What's that? Yeah, the reason why you have a plus sign is because you typed something before, and then you didn't finish what you were supposed to type. So when you now hit enter, it will go to the next line, waiting for you to put in what was remaining from the last line. For example, now if you do this, see, it's good you made a mistake, because that's how you learn in this kind of thing. Like now, if I say you were trying to type maybe help starts, help starts, and then you open this parenthesis, right, and you say enter, it will give you plus sign, meaning something is remaining, something is left. So because I know what is left, I'll just do something like this. If you hit enter, it will run the function. But assuming you don't know what is left, at times you don't know at all. Even to you wonder where did I go wrong. Just escape the place. Just say escape to come out from that place. Just hit escape, and then to give you a fresh prompt. Okay, good. So the function you want to do is help start, and like I showed you before, it opens this page. So this is the main R help page. So we have introduction to R extensions, data import export, the language definition, installation and administration, R internals. It's an open source software, so even the source code is open, is available. So that's what R internals is about. They tell you what is inside the guts of R. Then authors, search engine keywords, packages. So there's a lot of stuff here. It's actually overwhelming. It's overwhelming. What is here is R was invented in according to the year itself. It's been a long time, sir. R was invented I think 89 or so, thereabouts. And it was invented by academics for academics. So there's a lot of the resources are just it's just too much. It's like a universe. Okay. So usually you will not use this much unless when you get to using R. If you really want to use R a lot, then you have to start knowing some of these things here. But generally speaking, like before I started reading all this stuff, I had already started using R for like 2 years before I started even going here. So it's not really for you to. If you're the curious type, you can go there. All right. But where is our slide?
So you escape. You gave you the result.
Okay, this is our slide. All right. So you're cool now, right, Maureen?
Yes.
You got it. Okay, good. Now, but there's help. Help is more more day to day. Okay. So we have help functions. Okay. Every function in R has a help page. In fact, even if you are creating a function that you're putting into a package, you must create a help page for it. It's like a must. So to access the help, is this operator here called just a question mark. Sorry, it's somehow not visible. Okay. So if you put a question mark before any function, you want to know what is it all about. Just type question mark before it, and to give you the this thing. Let me just do that and show you. For example, we use the function here now. File. What was that function we use now? File edit. If I say question mark file edit and I hit enter, it opens a help page for file edit. Edit one or more files. Okay, you see the function here, the name here, the title, description, usage. This usage is for you that is learning R. Not even learning. Anybody using R has to always consult this thing. And I tell you, at least I've heard from people who are real old, in fact, people that even wrote the functions, they still consult these things because it's not something you go and memorize. That's why it comes with the references. For it to, if you're working with it, you refer to it and check what is in the function, how to use it, and everything. So file edit, it shows you how to use it. These are the parameters. Okay. Then what are the arguments? It just gives you what they're about. 1, 2, 3, like that. Details, for more details. Then it even gives you examples. Okay. So if you want to learn how a function works, you can just quickly run the examples. Okay. All right. Now, sometimes you just want to check the arguments. You can use this function args set wd. Tells you the function and gives you the arguments, just for reminders. Okay, so you don't need to open the help page, or Sometimes you just want to see some examples. If you just type example, there's a function called sum. So if you just type example sum, to just give it, it will run the function, run the example for you, give you the result, everything will just come out here. You can just see how the thing works. For example, this one says pass a vector to sum. Next time we meet here on Wednesday, I'll teach you about vectors. Alright? Pass a vector to sum, it will add the elements together. So sum, this is 1 to 5. 1, 2, 3, 4, 5. That's what this means. 1, 2, 3, 4, 5. It gives you the sum. It's 15. That's all. So that's the example run for you there. Pass several numbers to sum, and it also adds the elements 1, 2, 3, 4, 5. I think you see it, and it gives you the same result. So that's just what is. So this example will help you to at times just quickly when you say what does this thing do, you can just run the function example and just quickly see without having to go and check the documents, check the references. Alright, so we're done for this. Do you have any questions, please? Anything that wasn't clear or anything that was too clear? I'm missing Ernest. Where is he now? I was enjoying poking fun at him. Okay, so Oloma, you look like you have a question. Okay. Are you confused?
Me? No.
Okay, good. Uche, you came late, so do you have a question?
Yeah, but not on today's.
Go ahead, ask.
Installing the R Studio.
Mm.
It got to a point they started asking me for registration, and then it's requiring a license number.
You downloaded the wrong one. You downloaded the wrong one. There's a free version. There's an enterprise version. So you went and downloaded the wrong one.
Are you the one that downloaded it or the one that was
On his own. He did it on his own. That's why. So just discard that version. Go back to the site. Make sure you download the free version. The one that is, I think, is on far left. You see download. You see different options. There's one that is just for free. That's one you should download. Okay. I think this was quite straightforward, and there wasn't anything much. Okay. I don't have any exercises for you or anything like that. But from next time, I'll prepare exercise for you. Do the exercise. Yes. Okay, though. Thank you very much.